Hi and welcome to a new tutorial, and in this video we will implement the jaw movement. So the jaw movement is the movement where we can actually look around, so not up or down but left and right. So to do that we actually need to create a new class, and that class will actually involve some annoying matrix math, but that's no problem. So first of all, it's not a class, it's just a matrix for a matrix tree structure. So create. If you don't know like matrix math, it's no problem. I'll try to explain it the best I can. So go to matrix3.h, include glfw/glf3.h, and then so first of all create a new struct, type def struct, and this will be our matrix tree struct. So now I've created in total 9 variables here. Why 9? Well, we have a matrix tree, which means the matrix has 3 rows, and for every row there are 3 columns. So it has a total of 9 variables. So how did I name this? So this first variable is for the top left place in the matrix, so the first row and the first column. Then we move one spot to the right, so still the first row, but this time the second column, so 0, 1. And then the third column, 0, 3, and then we move up to the second row and the first column again, which is 0. Okay, it's quite simple. Then our first function will be, it will return a matrix tree, and it will be scalar multiply matrix 3. Then we need our matrix tree, so matrix 3, matrix, simply called matrix 3, and GLfloat scalar value. And this is our first function. And let's implement this. It's actually quite a straightforward implementation. Multiply, yes. So in matrix3.cpp, simply again type this function, so scalar multiply, I'll actually just copy it to be safe. So, alright. Okay. Now, and here's the implementation, and it's exactly the same as with the vector tree implementation. In this case, it's only the 9 times we do the multiplication, 1 time for every member of our matrix. Then for our second function, which we need, go back to matrix3.h and then create a new function, call it matrix3, and call this add matrix 3, and then simply do matrix 3 matrix A and matrix 3 matrix B. And again copy this and go to your .cpp file, and again let's create the implementation of this, which again will be very simple. Then here's the implementation. Again, it's extremely simple. We just take our matrix A and our matrix B, and then we simply add their variables, their corresponding variables, and assign that to the corresponding variable of our new matrix 3, Again, exactly the same as with the vector tree. Now for our interesting function, this will again return a matrix tree, and call this make rotation matrix tree. Now this one will be kinda more difficult, so bear with me. So this will take a couple arguments. The first one will be our angle, so GLfloat angle, and this represents the amount of rotation we want. This angle will actually be in radians, not in degrees. And then we need something to rotate around. So in our case, we actually need 3 axes. So first we need the x-axis, the y-axis, and the z-axis. And again, this simply represents, this represents, I'll actually show it, well maybe, and I'll show it, it will be much more clear, so bear with me. So I forgot to actually give this a type, so give it GLfloat to the x-axis, y-axis, and z-axis. GLfloat, oh god, okay, and GLfloat. Alright, like that. Then in the implementation, so here's the implementation. Now there's actually some complex matrix math. Well, not complex, somewhat more difficult. I won't explain this. It's difficult to explain, and yeah, just know that all this does is it creates a matrix which represents a rotation around an axis. And that was our matrix math for today. Then return to your player input system.cpp, and then so underneath where we set our GLF, well, where we do all of our stray stuff. Great. Well, actually, no, we need to do one more thing in for our vector tree. I forgot. So go to your vector tree.h. The first thing we need to add to this is is a way to calculate the dot product, and the dot product actually only returns one value. So not like the cross product, which returns a vector tree. The dot product will only return a single value in a GLfloat. So dot product product vector tree, and all we need for this is a vector 3 vector A and the vector 3 vector B. Copy this and got that. Alright, and then it's implemented. It will be very simple. So all the dot product is, all you have to do is create a new, you can actually do this, return, and then all you have to do is multiply the corresponding values of our vectors. So vector a dot x multiplied with vector b dot x, and then we take that and we add this to the following. So now vector a dot y multiplied with vector b dot y, and then we add this to vector a dot c and vector b dot c, and this is the dot product. Very simple. Then, so in the .h file, our final function will be vector 3 transform vector 3, and this will take a vector 3, simply called vector, and it will also take a matrix 3 namely the transformation matrix. And we also need to include matrix 3.h and matrix 3. Alright, here's our definition of our function, and to transform a vector we need to calculate the x, y, and z components of that vector, and to do that we have to calculate the dot product of the vector and every column of the matrix. So that's what we are doing here. We are calculating the dot product of our vector and of every column of our matrix, of our transformation matrix. It's actually just like multiplying two matrices. Okay, and this was all of our math, and now we can actually implement the fun stuff. So go to play your input system.cpp. Well, we actually need to create one more thing. We need to create a vector 2. I'm sorry, I forgot about that. So simply create two new files and name them both vector2.cpp and .h, of course, and create, and this will simply contain a struct, which is this vector2, and this will simply contain a struct to hold two components. So let's simply do timedef struct struct, and this will be vector2 and then simply do GLfloat x and GLfloat y, and of course don't forget to include glf/glf.h glf3, and that's it, no functions. Alright, so then go to player input system.h actually first, and include our new vector2. So include vector2.h and create a new variable, and this variable, it will store our last mouse position, and I'll explain what that is. Then go to player input system.cpp and then in here. So in our constructor we will initialize our vector2 with the current mouse position. So simply do vector2, do glf get cursor pos of our current window, and then do last mouse position dot x and add, because we need to pass it as a reference, and add underscore last mouse position dot y, and that's it. Yeah, one more thing. GLf get cursor position actually wants two double values, so let's simply go to vector2.h and change this from GLfloat to GLdouble. Like that, and this error should go away, and this, well, it's gone. Okay, then let's actually create okay, so the first thing we need to do is get the current mouse position. So type vector2 current mouse position, and then again do glf get cursor position of window underscore window, and then current mouse position dot x, and add current mouse position dot y. Now our fun method, our fun line. So do what's it called? It's called the I vector. I hope it's called the I vector. Oh, what the hell are we doing actually? Just copy this and oh my god, I'm sorry. Go to update. Wow, what a screw up. And before we set the I vector. Yes. So in here, before we set the I vector. Alright, I'm sorry guys. Do I vector equals then transform vector 3, the I vector, and then make rotation matrix and our angle. Now, our angle will be the following. We will take 35 degrees, which is B, which is simply 3.14f, and divided by 4.0. This is actually 45 degrees in radians. Then for our sensitivity, let's multiply this again with 75.0f. Then what the hell is this? Then it's correct. I hope it's correct. Then we will multiply all of this with minus, or I'm not sure it's minus, but doesn't matter. Current exposition, current mass position dot x minus last mass position underscore last mass position dot x, and now here are the three variables for the axis around which we will rotate. Now, for the horizontal rotation, we want to rotate around the up vector. So simply do 0, 0f, 1, 1f, and 0, 0f. And that's it. And somewhere there is this one. Yes. Okay. Now in theory this should work, but it doesn't because there are some mistakes here. Of course, in our matrix v.cpp we should actually include math.h, and then we have one more. Of course, yes, I forgot about this. Yeah, so go to matrix 3.h and let's create a variable here, and you can call this the identity matrix. And what this is, it's it's a matrix which consists of the following variables. Fill in these values, so everything is 0 but this diagonal row here. Now, what is the identity matrix? Well, essentially, the identity matrix is for matrix multiplication, what 1 is for simple number multiplication. So any value that we multiply with 1, we will get that same value. And the same goes for the identity matrix. Any matrix we multiply with the identity matrix, we get that same matrix. This is very popular in matrix math and very useful. And that's it, I hope, of our mistakes. And when we run this, still one more. Identity, okay, sure. And maybe it's best to call it identity matrix 3 because we can have multiple identity matrices, so like that. And make it a constant, please, to prevent any errors. Then go to your player input in CVP so we can finish up that. And all we have to do here is actually set our last mass position. So our last mouse position, well actually, so GLF get cursor position, window, and simply do add last mouse position. And this way we will reset our last mouse position every time we call this function, so we can use it again next time. Okay, so if everything goes according to plan, this should work now. And here we go, and it's working perfectly. We can now move around and rotate around our single cube. We can't do the vertical movement yet, the pitch movement, but this seems to work nicely. This is a pretty long video, so I think I'll leave it at this. So again, the source code will be in the description, and I'll also give the definition of some of the more difficult functions we did, like the make rotation matrix tree function. Okay, and yeah, I hope you enjoyed this, and I'll see you next time. Bye.